Okay, today we're going to talk about integration by substitution, or simply the reverse of the chain rule. So, before I spend a lot of time explaining this, I think you should know that Professor Dave explains this extremely well, and sometimes him or Revision Village, wins the prize of who explains it well. But both of them have uh, good explanations. So this is something that I got from the Australian textbook, which basically says when you take the antiderivative, like I said, Professor Dave explains this so well. I just want you to hear his explanation. So if you go to his YouTube video, Professor Dave explains integration by substitution. He explains this question. If you go to minute 047, he explains this really well. You can hit pause and look at my work, but listen to his explanation. Okay. This is his second one that he explains. And here's the third question he explains. Hit pause if you need to. Here is the fourth one that he explains. And then if you go to Revision Village, YouTube Revision Village integration by substitution, here is the first one that they did. At first I thought absolute value was necessary, but then I realized it's not, because x squared will always be positive. So that's useful to know. And these examples here, 6 and 7, those are also done by Revision Village. Whoa, what is going on? That was weird. Okay, now let's talk about this one that's not from Revision Village, from our textbook. Here, I'm going to use highlighters to explain this. Okay, so so basically you've got this question. It says dy dx equals e to the power of 2x minus 2. So the first thing that we're going to do is we can take the derivative of the left side and we get y, and we take the derivative of the right side and we get the derivative of e to the 2x minus 2 dx. Okay, and then what I see here is I want to make 2x minus 2, I'm going to let u equal that. Okay, and then just looking at just that, the derivative of u is du, and the derivative of 2x minus 2 is 2 dx. The derivative of 2x is 2 dx. And so then I want to we want to make a substitution. We want to get rid of this dx, and we want to turn things into du, because I'm going to replace the 2x minus 2. I'm going to replace that with u, and so the derivative of u is du. The derivative of 2x minus 2, the derivative is 2 dx. And so, but I want to replace the dx. So if I have this line here, and if I divide it by 2, then I end up with dx equals 1/2 du. So now I'm going to replace dx with 1/2 du. I substituted that for that. Okay, and so now I could put the 1/2 on the other side. I don't have to, but you may as well. And then I have the integral of e to the power of u du. And so then we can use our integration rules, that the antiderivative of e to the x is equal to e to the x plus c. So here I have e to the u du, so that antiderivative of that is e to the u plus c. Okay, and then final step, I resubstitute. I'm going to replace u back with 2x minus 2 plus c. Now, um, um, we want to find c. Okay, we need to calculate c, and they've told you that when x is 2, y is equal to 1. So what I'm going to do is I'm going to replace y with 1, and I'm going to replace x with 2. Okay, and then I get 1 equals 1/2, and then 2 times 2 minus 2, that's going to give me power of 2, and then so I've got 1 equals 1/2 e squared plus c now. I can bring the 1/2 e squared to the other side of the equal sign, use my calculator, get an approximation. Okay, we're going to do the same. Let's see what else. What's the next problem? Okay, so the next stuff is just their homework problem. So what we're trying to do here is figure out what we're going to make with u. So here we've made 4x minus 1 our u value. Okay, and then once we figure out what we're going to make u, then we need to figure out how do we make this du. So to make this, to figure out, to convert dx to du, I did derivative of u, we did du. The derivative of 4x minus 1 gives me 4 dx. So divide both sides by 4. We know that dx is going to be 1/4 u. So I'm going to replace dx with 1/4 u. And so now I've got antiderivative u squared times 1/4 du. We can factor out the 1/4, and then the antiderivative of u squared du is going to be 1/3 u cubed. Okay, same process here. Actually, even the same numbers, 4x minus 1. Okay, actually, all 4 of these are with 4x minus 1. Okay. Hit pause if you need to. On this one here, I rewrote this square root in the denominator as to the negative 1/2 power. Okay, and on this one here, we took the absolute value here because when you're taking the absolute value, or when you're doing a natural log, it has to be positive. Okay, and then that's what this guy is saying here. It has to be. I don't know why he doesn't explain. He just says it's a useful result. Well, duh, it's a useful result because it has to be positive. Okay, and Professor Dave explains that explicitly. Revision Village did not explicitly explain that. Okay, so I've got two things I'm taking the antiderivative of. I've got the antiderivative of x and the antiderivative of 1 over x squared. Okay. The antiderivative of x dx is 1/2 x squared. The antiderivatives, so it's useful to make u equal to x plus 2, and then the derivative of u is du. Derivative of x plus 2 is dx. I don't know why I have that there. And so, and there we go. This, I think there should be an absolute value here. Okay, and then I replace the u back with x plus 2, and now we need to find out what c is. So just like in the example on the previous page, we're going to make x equal to 0 and y is equal to 3. So I'm going to replace y with 3. I'm going to replace x with 2. No, x with 0, sorry. So I have 0 plus 2, that's going to be natural log of 2. and I've got the 0 there, so that's going to go away. And now we can get c is equal to 3 minus natural log of 2. And so here is the final answer. Okay. Okay. Here. So I hope now you're starting to get the hang of it. And let me just put this here. You can hit pause, check your work. Okay, I'm going to move it up. You can hit pause to check your work. I think this one was a little tricky. Okay. And the last one. Okay. There you go. Let me know in class if you want me to explain any of these a little bit better. I'm happy to do that and make a second video because my students next year, this will be useful for them as well. Thank you.